This is a star, not a decoration in the sky, but a controlled catastrophe, an object so violent that darkness itself appears to retreat from it. Every second, it crushes matter, releases unimaginable energy, and throws heat across distances so vast that entire planets survive only by keeping their distance. From far away, it looks peaceful. Up close, it is an ocean of plasma, magnetic storms and explosions large enough to swallow the Earth without leaving a trace. And yet, from this violence come the gentlest things we know: warm mornings, blue skies, liquid oceans, forests, breath, blood, life. But stars are not eternal. One day, the universe will create its final star, and after that star dies, the cosmos may never create another sunrise again. A star does not begin with fire. It begins inside darkness, within an almost invisible cloud of gas and dust drifting between the remains of older stars. Then gravity discovers the smallest imbalance. A slightly denser region pulls in more matter, becomes heavier, and begins collapsing beneath its own growing weight. The cloud folds inward. It spins faster, grows hotter, and gathers so much material that a newborn object begins glowing inside its dusty cocoon. At its center, pressure becomes unbearable. Hydrogen nuclei are forced together. Fusion begins, and for the first time, a new star pushes its light into the universe. From that moment, the star enters a lifelong war. Gravity fights to crush it inward. Fusion fights to tear it apart. A star is an explosion that never quite escapes itself. The young universe had no mountains, no oceans, and almost none of the materials needed for life. It was mostly hydrogen, helium, and emptiness. Stars changed that. Deep inside their cores, they became the universe's first factories, crushing lighter atoms together and constructing entirely new elements. They forged carbon, oxygen, silicon, and iron, the ingredients that would eventually become air, stone, machines, oceans, and living cells. But many of those elements remained trapped inside the stars that created them. To release their treasures into the universe, the stars first had to die. The star detonates, scattering its remains across space. The iron in your blood, the carbon in your cells, and much of the calcium in your bones came from stars that died before Earth existed. For ages, creation appeared unstoppable. Galaxies blazed across the darkness, each carrying billions of stars through space like enormous islands of fire. Enormous nebulae became stellar nurseries. Inside their glowing pillars, gravity produced hundreds of newborn suns, each fighting its way out of the darkness. Around many of those stars, leftover dust assembled into planets. Some froze, some burned, and perhaps some waited quietly for chemistry to become life. Across the observable universe, new light appeared faster than any mind could count. The cosmos had entered its magnificent age of fire. This is the era in which we live, bright enough for stars to fill our sky, yet calm enough for life to stand beneath them and wonder where they came from. But the universe is spending something it cannot replace. Every newborn star consumes part of the cold gas inherited from the generations that came before it. When galaxies collide, they compress their remaining gas and briefly produce brilliant waves of new stars. But every celebration leaves less fuel behind. Over unimaginable time, stellar nurseries become rare. Galaxies once filled with fierce blue stars turn red, quiet and ancient. The universe is not endlessly creating. It is converting a finite inheritance of cold matter into light, light that escapes and can never be gathered back into the stars. Long before the final star dies, the cosmos will already feel empty. Fewer births, longer nights, distant galaxies fading beyond reach until their light can no longer find us. Our sun obeys the same law. In roughly 5 billion years, the hydrogen in its core will become scarce, and the balance that sustained it will begin to fail. The sun will swell into a red giant, becoming hundreds of times larger and turning the inner solar system into a furnace. Long before the sun reaches its greatest size, Earth's oceans will boil away. The atmosphere will escape, the surface will melt, and every familiar landscape will disappear. Larger stars die far more violently. Their cores collapse within seconds, followed by explosions powerful enough to briefly outshine entire galaxies. Some leave white dwarfs. Others become neutron stars or black holes. Every kind of star has a different death, but none receives an exception. Every light is already moving toward darkness. The final ordinary survivors will be red dwarfs, small, dim stars that consume their hydrogen with extraordinary patience instead of burning through it recklessly. Some may continue shining for trillions of years, long after stars like the sun are gone, and the galaxies around them have changed beyond recognition. From a world beside one of these stars, the sky would appear almost empty. Cosmic expansion would have carried distant galaxies permanently beyond the visible horizon. Eventually, only a handful of red stars would remain, separated by oceans of darkness wider than anything the living universe ever knew. And then there would be one, the last star in existence, burning alone, while everywhere else in the observable universe, sunrise has already happened for the final time. For an age beyond comprehension, the final star continues. Then, its core weakens, its surface dims, and the final stellar light disappears without anyone remaining to witness it. What remains is a cosmic graveyard. Frozen planets, dead white dwarfs, neutron stars, and fragments of matter drifting without warmth, direction, or sunrise. Black holes outlive almost everything. They swallow the occasional wandering object, merge with one another, and become the final great monuments of gravity. But according to current physics, even black holes cannot survive forever. Through Hawking radiation, they leak away particle by particle until the final black hole also disappears. Then comes the universe's longest chapter. No stars, no warmth, no dawn, only darkness expanding into darkness. And that is what makes this moment extraordinary. We are alive while the universe